Hello out there, guys. I hope you're ready today to work with me. We'll be focusing on representing of data, okay? And remember, when you do your mathematics, you need a pen and paper. It's not about observing. You need pen and paper, your calculator with you to try some of the problems, okay? And to think about some of the questions we'll be asking you. My name is Rakabu. I hope you're ready. This is going to be one of the good lessons. Okay, let's look at what we have today under representing of data. So under representing of data, before we do that, I have some few questions for you to answer. Let's look at the first question. How can an investor reduce risk on investment? Okay, so you have a lump sum of money, or it's an investment company, and you want to reduce risk. When I talk about the risk, is that you don't want to lose your money. Okay, so how do you protect that money? Okay, so usually investment companies, they take money, invest, or they buy stocks. So you want to study those companies. And to study those companies, you need data. How's their performance? How is the past 5 years return in terms of profit? Something like that. So we really need data also in investment if you want to invest and check, and we can able to calculate risk. And later we'll actually able to quantify what is this risk using a variable. Okay. What about the second question? Which is, how does a bank calculate the interest rate on a loan when one borrows money? Have you ever thought about that? How does a bank calculate the interest rate? You want to buy a car, and the cost of a car is 200,000 or something. You don't have 200,000 with you. You want to borrow the 200,000. So surely an interest rate, a bank will give you interest rate. How does it calculate that? Usually, you have companies that study individual. They collect data about you. When you default on a payment, I mean you miss a payment, they keep that. Okay, and so on. Then when you go to a bank, they check the data. They say, oh, person A, you had a loan there, a loan there, a loan there. You're paying all of them. But also they can check based on the data whether you can afford, okay? And surely if the probability or the chance that you might miss a payment are very high, they'll give you a higher interest rate. So data can be used in different ways, from a loan, individual person, or just calculating a risk also. Okay, fantastic. I hope this makes sense. Now, let's look at more questions to think about. Does lockdown reduce the COVID-19 from spreading? Okay. What is a lockdown? By a hard lockdown, no movement, you have to be at home unless you go and buy essential service. And lockdown get eased also, but do you think, personally, does lockdown reduce? Based on data we've been observing, yes. After lockdown has been eased, relaxed, we're allowed to walk, we can go for a run, we can go to a park, then numbers of infection started increasing based on the data we observed that, yes, a lockdown can actually decrease the COVID-19 infection. Okay. I hope you thought about this by now, and it's a nice question to think about it. Let's look at another one. So, also related to the COVID-19, how long will the second wave of COVID-19 last in South Africa? Any view? So when I talk about the second wave, I mean the first wave, it's when the COVID-19 started. We had like a hard lockdown, then lockdown was eased, and I think the maximum infection daily report was approximately 13,000. So we had something of this nature when we started. So we had a maximum, then it started decreasing based on data. So here was the maximum amount of infection, then it started decreasing, so on, because of the lockdown there. Okay, because of the lockdown. Then now, will we have a second wave? Second wave will be this second part, because now we're decreasing. It's going up. Will this part be higher than this or lower than that? Okay. In simple terms, will the second wave, will we have more than 13,000 cases reported now? Because in the first wave, the maximum was about 13,000. Can we record something like that? I think we're getting close to that. But to answer that question, we don't have data. We can try to predict, and we might be wrong, but we can wait for the data and see what is happening. But one can sense from the current data that we're actually approaching that the second wave might be close to the first wave, or even higher than the first wave. Good, interesting question of what is affecting us. Lastly, how can we tell if the second wave is higher than the first? Okay. I mean, the first wave, we know the maximum infection was around 13,000. We will tell if in the second wave we can record around more than 13,000 daily infection. Okay, that's how we can tell if the second wave is higher than the first wave of the COVID-19. Okay, interesting question. So data is used on a daily basis. It can be in reporting of the pandemic, can be used by the bank, can be used by the investment firm, anywhere. Data, it's around us. And this is the world of data and statistics. It doesn't matter. Data is not for engineers, for scientists, for biological science. Even as psychologists, you need understanding of data. I mean, now we're actually in the fourth industrial revolution. And the fourth industrial revolution is about the collaboration of human, us, and machines, okay? And that, most organizations that understand data will able to make lots of profit. So this is the world of data. So it doesn't matter what kind of career, sports scientist, anything, one need a little bit of understanding in the fourth industrial revolution. Fantastic. Let's see what we have now. So what are we going to look? We'll look at, this is some of the stuff we look, line graph, bar graph. This is how you can represent data, pie chart. We'll look at some of them. Pie chart, box and whisker, we'll discuss that. This is just the box which contains the minimum value, the maximum, the middle, and the lower and the upper quartile. We'll also look at the scatter plot, histogram, and frequency table, frequency polygon, and cumulative frequency. Okay. So let's look at some of the keywords, which is cumulative frequency and frequency. Cumulate, what does cumulate mean? Cumulate, if I have 10 Rand, tomorrow I have 20 Rand, then I have 30. I keep on adding, but I'm accumulating that. Does that make sense? Even if you look at how the COVID-19 is reported, you add daily cases from the current, from the total. So you keep on accumulating. Okay, does that make sense? Okay. Then frequencies. Frequency is the total tally, okay? So if I make an example, I'm going to make an example using the pandemic. Let's say people who are affected by the pandemic between the age of 19 to 30, if the total is 100,000, then the frequency is 100,000 in that interval. Does that make sense? Okay. So we're going to look at another word, which is frequency table and tallies. So frequency table, okay. Remember, in data, we can have grouped data or raw data. We can group data, for example, if you go back also, which is interesting, the COVID cases, some of them are grouped according to age in terms of infection. So that is a frequency table. We have kids between the age of 0 to 9, how many actually died from the COVID-19? We have a number. Between the age of 9 to the age of 20, how many? Between the age of 20 to 30, how many? How many that? It's frequency. And that is the frequency table, okay? Because you have an interval and how many in that specific. Does that make sense? Okay. Then the tally is actually the total in that interval. Interval meaning, let's say, between the age of 0 to 1, how many people died with COVID-19? We count them. Those are the tallies, which give us the frequency. Are we all together? Okay, fantastic. So it's a frequency and tally. Now we're going to look at more keywords, which is discrete data and continuous data. Discrete data, it's like specific, like 1, 2, 3, 4, 5. That's discrete data. If I have a dice, I roll a die. I can get 1, 2, 3, 4, 5, 6, which is discrete data. It takes a specific value. But what about continuous? Continuous data can take any value, something like temperature. Today, it could be 31.5 degrees Celsius. Tomorrow, it could be 31.5 degrees Celsius. So it takes any data set. So we're discrete, a specific value. Okay, fantastic. That's the difference between discrete and continuous. I'll be using that kind of terminology as we continue. So we will look again. If you go back, this is what we will focus on: the bar graph, line graph, and the whisker plot. Scatter chart, cumulative frequency, frequency polygon. This will be defined later. All the bar graphs, some you might be familiar with, and the whisker plot. Okay. So what are we going to do now? When we come back, we're going to take a break now. And after the break, we'll come back and look at the bar graph and the histogram, okay? So let's take a short break. And I want you out there to think about, how does the bar graph and histogram look like, okay? So sit there, think about it, and after the break, we'll go through the two representation of data.